So now we discussed about power quality measurement equipment. Which equipment is used for power quality measurement? So power quality measurement equipments are basic categories of instrument that may be applied include wiring and grounding testing device. Normally ground testing by using meggers or multimeters. So if there is a continuity or not, we can use that one, meggers or multimeters. Second one is multimeters. So what is the purpose of multimeters? Multimeters measure the voltages and currents and resistances in the system. Oscilloscopes gives the clear waveform. So that is a sinusoidal or non-sinusoidal. Which wave will be exact waveform will be observed by using oscilloscopes. So how much harmonics are present in a waveform we can easily analyze by using oscilloscope. Disturbance analyzer also if there is a sinusoidal waveform on that sinusoidal, which time they have a disturbance, which time they have a transience, which time they have a surges, we can easily analyze by using disturbance analyzer. Harmonic analyzer and spectrum analyzer. So the oscilloscopes, disturbance analyzer, harmonic analyzer and spectrum analyzer gives we collecting the wave from source is a exact sinusoidal or not. Any disturbances or occurs, any deviation occurs, we can easily determine that one. Combination of disturbance and harmonic analyzers. Flicker meters, energy monitors by using normal devices enough for energy monitoring. So what is the input of energy, what is the output of energy? So regardless of the type of instrument needed for particular test, there are a number of important factors that should be considered when selecting the instrument. Some of the more important factors include number of channels, voltage or current, whatever it is, temperature specification of the instrument, ruggedness of the instruments, input voltage range, that is a 0 to 600 volts normally, power requirements, ability to measure three-phase voltages, so next one is input isolation between input channels from each input to ground, or ability to measure currents, housing of the instrument, that is a portable, rack mount, etc. Ease of use, that is the user interface, graphics capability, etc. Documentation, communication capability, modem or network interface, analysis software. So multimeters, normally multimeters are used for phase to ground voltages. So that also we measured by using multimeter, we can measure also phase to neutral voltages, neutral to ground voltages, phase to phase voltages, and phase currents and neutral currents. These all are the measured by using the multimeters. So in multimeters they have different types of multimeters. That is a peak method. So the multimeter is give the voltage by using peak method or averaging method or true RMS. You must identify that one. So what is meant by peak method means assuming the signal to be a sinusoidal, the meter reads the peak value of the signal only. So in sinusoidal waveform, which is the peak value that can be measured by using the peak method of multimeter and divides the resulted by 1.414 to obtain the RMS. Second one is the averaging method. The meter determines the average value of rectified signal. Average value and every instant value we can collect the every instant value, we can do that averages. So I1 or V1 plus V2 plus V3 plus and so on up to Vn by n is related to the RMS value by a constant. Third one is true RMS. The RMS value of a signal is a measure of heating that will result if the voltage is impressed across a resistive load. One method of detecting the true RMS value is to actually use a thermal detector to measure a heating value. More modern digital meter use a digital calculation of the RMS value by squaring the signal on a sample by sample basis, averaging over the period and then taking the square root of the result. These different methods all give the same result for a clean sinusoidal signal but can give significantly different answers for distorted signals. This is a very important because significant distortion levels are normally the multimeters are used in true RMS is very useful multimeter. Disturbance analyzer. There are basically two categories of these devices. Conventional analyzers that summarize events with specific information such as over voltage and under voltage magnitude, sags and surge magnitude and duration, transients magnitude and duration, etc. Graphic based analyzer that save and print the actual waveform along with the descriptive information which would be generated by one of the conventional analyzer. So the first one is a conventional analyzer, second one is a graphic based analyzer. So please see this graphic based analyzer. So exact where the disturbance occurred, that gives the disturbance analyzer. Please see the waveform is positive 1000 volts, negative 1000 volts. Please observe the waveform. This off cycle continuously disturbances. Particular this time there is a continuously disturbance occurred. This disturbance is measured by using disturbance analyzer. Spectrum analyzer and harmonic analyzers. So spectrum analyzer means in between which frequency having the disturbances occurs, in which how many waves are there is a harmonic component that can analyze by using spectrum analyzer and harmonic analyzer.